Hi guys. So this is the notes for arc length. So arc length is going to be the distance or the length of a piece of a circle, right? An arc's part of the circle. So what we have here, if we go around the entire circle, is a circumference, right? So we know that the circumference of a circle equals 2 pi r, right? So the distance around that circle is 2 pi r. But an arc length, right? An arc is part of a circle. So if we look here at this one, let's just assume that was, say, 110 degrees. All right, let's assume this was 110 degrees. Okay. We're looking for the length of just this piece. So we need to figure out what portion of the circle that is, right? A circle is 360 degrees around. So we're looking at 110 degrees out of 360 degrees. So 310 divided by 360. Whoops, I'm sorry, 110 divided by 360. All right, that's 0.31. So that's going to equal 0.31. So it's really 31% of the circle. The arc is 31% of the circle. So if we want to find its length, we'd have to multiply that by our circumference, right? So it's portion of the circle, right? It's basically arc length, if I abbreviate as AL, right? You have the part of the circle, right, times the circumference, right? So we're going to take what part of the circle times the circumference, and that's going to give us the length of that piece. So if the measure of the arc is 110, we know we would have 110 over 360, right? And then it would be circumference is 2 pi r, so 2 pi times, let's just say the radius was 3 inches here. It'd be 2 pi r times 3, right? And so you have arc length equals 110 divided by 360 times 2 pi times 2 times pi times 3. So there's 110 divided by 360 is 0.31, right? And then times 2 times pi. Then we said our radius was 3. So that's going to be 5.76. So that would give us 5.76 inches, right? And that would be our arc length here, assuming that the arc measure was 110 and the radius was 3. If we find the circumference, right, so that would be 2 times pi times 3. So 2 times pi times 3. The 6 pi, which is 18.85 inches. Right, we notice how our arc length is about 31% of 18.85, right? If we did 18.85 times 0.31, right, that gives us our arc length of 5.84. So the idea here is the arc length is simply part of the circumference. In this case, in our example, it's 110 out of 360, so it's 0.31. It's 31% of the circumference. Okay, so let's do some example problems on arc length. Let me zoom in a little. And let's probably zoom in a little more. Okay, so the first one here, find length of arc EF. That's this arc here. We know the measure of EF is 120 degrees. Right, so if we have our arc length formula, right, it's x over 360. So what portion out of 360 degrees times the circumference, right, which is 2 pi r. Right, so you can put a c there if you want, or you can put 2 pi r. Okay, so we have 120 out of 360. So that's going to end up being 1/3 of the circle, right? The length of the arc is 1/3 of the circle. right? 120 divided by 360 is going to be 1/3. And then 2 pi r, that's going to be 2 pi, and then your radius is 6. Okay, so our arc length, again, it's 1/3 of the circumference, so that's 12 pi, right? 2 times 6 is 12. So our circumference is 12 pi, but this arc is only 1/3 of the whole circle. So we need to multiply those together. 1/3 of 12 is 4, so that's going to be 4 pi. And then our unit was meters. Okay, so the distance around the whole circle is 12 pi, but the distance around our arc, the length of our arc here, was just 4 pi, 1/3 of that whole thing. Right, number 2 is very similar. So again, arc length, our formula is x over 360 times 2 pi r. Okay, right, the portion of the circle times its circumference. We have a diameter of 24, which means our radius is half of that. So our radius is going to be 12 centimeters. All right, and then we can just use our formula. So we're looking, the measure of arc CD here is 60 degrees. Right, and again, the arc measure is different than the length that we're trying to find. The measure is the portion out of 360. The length is the actual distance. Okay, so arc length equals, we're dealing with 60 degrees out of 360, so that's 1/6 of the circle. All right, and then we don't want the whole circumference. We only want the 1/6 of it, so we have to do 1/6 times that circumference, which is 2 pi r, so that's 2 times pi times 12. All right, so our circumference is 24 pi. Right, but we don't want the whole thing, we want 1/6 of it, right? Because 60 divided by 360 is going to be 1/6, which is our arc length. Okay, and then you multiply those together, so 1/6 times 24 pi, we're going to end up with 4 pi. All right, and the units again on that is centimeters. So 4 pi centimeters. It's going to be our arc length, right? 24 pi around the whole thing, but only 4 pi from C to D. So the length of arc CD is 4 pi. All right, let's go up to example number 3 here then. So a circle has an arc whose measure is 80 degrees and whose arc length is 276.46 pi inches. And we want to find the diameter of the circle. So that means we're going to have to find the radius first and then multiply by 2. So if we look at our formula, we have arc length. Okay, that's going to be equal to the portion of the circle, so x over 360 times the circumference, 2 pi r. Right, so our arc length, they're giving us the arc length, so we're going to substitute that in. So 276.46 pi is our arc length. And then we're looking at 80 degree arc. Okay, so that's 80 out of 360. 80 of the 360. Okay, and then we're going to multiply that by our circumference, which is 2 pi r. And then we don't have the radius, that's what we're trying to solve for. So 2 pi r. Okay. I'm just going to do what's on each, I'm going to simplify each side of the equation first. So on the left side, we have 276.46 pi. So I'm going to put that in. 276.46 times pi. And that's going to give me 868.52. So 868.52. On this side, we have 80 divided by 360 times 2 pi. So we're going to do 80 divided by 360, and then times 2 times pi. Okay, that's 1.39, so 1.40 times r. All right, we're trying to solve for r, so we got to divide now both sides by 1.4. Divide by 1.40. So 868.52 divided by 1.40, which was our answer. And that's going to give us 622.0. And that should be inches, right? So 622.0 inches equals our radius. That was our radius. If I could. I equals R. Right? And we want the diameter, so we need to multiply by 2. So that's going to be 1,244.1, 1,244.1 inches. Then would be our diameter. Okay. Diameter is twice the radius. All right. And then our last one here. I'm going to delete this so we can read it. Okay, find the measure of a central angle if an arc if its length is 43.98 pi and its radius is 18. So again, we're using the same formula, right? Arc length equals the portion of the circle, so x over 360 times the circumference, which is 2 pi r. Okay, they're giving us the arc length and the radius, so then our only variable left would be the central angle, which is the x. So we have 43.98 pi on the left side. That's our arc length equals, again, x over 360 times 2 times pi times the radius is 18. Okay. So I'm going to divide both sides by, again, we're trying to get x by itself, so I'm going to get rid of the 2 pi r. I'm going to divide both sides by 2 times pi times 18. All right, so these cancel. And 2 pi and 18. Okay, the pi's are going to cancel out here. 2 times 18 is 36, so it's 43.98 divided by 36. So 43.98, right, divided by 2 times 18 is 36, so divided by 36. Whoops. Divided by 36. 1.22. All right, equals x over 360. All right, and then you multiply both sides by 360. Okay, so we're going to multiply by 360. That's going to give us 439.8 degrees for x. 439.8 for x, right? You multiply 360 on both sides, those cancel out. So we probably shouldn't get a central angle that's large. It should be less than 360. So let's look and see if we did anything wrong. So 43.98 pi equals x over 360 times 2 pi times 18. That's 36 pi. So we divide both sides by 36 pi and multiply by 3. So that's good. It's just the numbers are very weird for that problem, whoever made it up. All right, so you can use this formula to find the arc length. If they give you the arc length, you can then use it to find the radius or diameter like we did in example 3, or to find the central angle like in example 4. Okay, so that's the notes for arc length, and then we'll have a separate video for the sector area. We don't want to make it too long.